So this is lesson 7, talking about Millikan oil drops experiment. And this experiment basically helped scientists, Millikan was able to determine the elementary charge. So when they say what is charge for 1 electron, I don't know if you remember that number. The number is 1.6 times 10 to the negative 19. How do they do that? How do they find out what is the charge for 1 electron? Okay, so it's basically through his experiment. And hopefully you've already watched the video that I posted beforehand, so you have a background of what the science or kind of the discovery route it is. So around 1900s, understanding the electric force, scientists is now wondering what is the smallest unit charge and how they do that. So this picture basically is able to kind of demonstrate to you with a couple of key things. Okay, number one, things that you do know is that you do know that there is a parallel plate. And the parallel plates, they know the distance between the parallel plates. Okay, they know the charge of the parallel plates. Okay, if this is an electron, what happened is, if we want to suspend, meaning leaving this thing kind of hanging in the middle, we need it to be repelling the negative at the bottom and having the positive at the top. Okay, what we do know is that they basically would be able to have a certain potential difference that they could know. And then acting on this is that there are actually two forces that are acting on this drop of really thin, small drops of oil. We know the force of gravity is pushing it down. At the same time, because I said there's repelling and attracting at the top, there's actually an electric forces that are putting it upwards. So it's kind of step one of what needed to happen is that, let's highlight it. You need to know it for your test. Okay, number one is you need really tiny oil drop. We call this the Millikan oil drop experiment. This is the step. Step number one, they use this thing called an atomizer. Atomizer is basically spraying off really small droplets of oil particle. You actually can buy atomizer now that you can actually increase the pressure to have really little bit of oil when people are cooking. That's called an atomizer. So they want really small drops of oil because they want it to have it so small that it can only be containing a few electrons in it. Okay, they want it really super small. And then what they do is they actually allowed it to go through this thing called the charge friction. So they charge it up by either gaining or losing a few electrons. So that's number two. So they charge up the oil drop. And then the third thing that it has to do is it's going to go through an electric field that are uniform, and that only happens between a parallel plate. Okay, so let's go back to the picture. So this is step one, the atomizer. Okay, step two is they charge it up. Okay, step three is having it go through the parallel plate, a uniform electric field. And then now that we know, we are actually trying to suspend the oil drop. And knowing that that oil drop will have an upward force and a downward force. The upward force is the electric force and the gravitational force is downwards. And then somebody is looking on the side here, trying to look at it, and they would adjust the voltage on the outside until it stays right in the middle. Okay, and then they wanted to measure the terminal speed so it's not accelerating anymore. And in that way, they can calculate the mass of the oil drop. Okay, so he repeats this over and over again until he's able to find out kind of a consistent pattern that they're seeing. All right, so we said that Fe equals to Fg. You can, I don't know if you want to write it out, but I know that Fg is m times g, right? And I know that Fe is Q epsilon. We're going to leave it as a positive value. We're not going to worry about the charges of it. Okay, and the other thing we also know is between the parallel plate epsilon electric field is delta V over R. Delta V for the potential difference of whatever the battery is. The R is the distance between the plate. Okay, and so we plugged everything in. So I have QE, Q epsilon is mg, and knowing epsilon is delta V over R, you can indirectly calculate the charge by bringing the R to the other side and the delta V by dividing. And this is how he indirectly worked out what is the charge. So he repeated it over and over again. And finally, kind of the scientific acceptable value of what E, the elementary charge, is 1.6 times 10 to the negative 19. Okay, elementary charge, or basically the charge for 1 electron. And since we know protons has the same charge, it's also 1.602 times 10 to the negative 19. And we also know the excess and deficits of electron, okay? Charge is N times E. If I have 5 excess of electron, the charge will be 5 times that. And finally, indirectly, they were able to find the mass of the electrons. Okay, so calculate charge on a small spheres with the excess of that many electrons. So they wanted to find Q, and they tell you that N number of electron is 5 times 10 to the 14. And this is what you need to know is 1.602 times 10 to the negative 19 coulombs. So multiply it in. So this is just a straightforward multiplying equation. So 5 to the exponent 14 times 1.602 exp negative 19. So 2 sig dig, so 8.0 times 10 to the negative 5 coulombs. Next question. In a Millikan type experiment, 2 horizontal plate is 2.5 centimeters apart. A latex spheres mass of 1.5 times 10 to the negative 15 remains stationary with a potential difference between the plate being 460. Upper plate is positive. What is the sphere's charge? Is it negative or is it positive? Calculate the magnitude of the charge and calculate how many excess or deficits of electrons. Alright, so they tell you the distance between the two plate is 2.5 centimeters. So divide that by 100 to get your meters. The mass is 1.5 times 10 to the negative 15 kilograms. So that's a good unit. Potential difference is delta V is 460. And the upper plate is positive. So if this is positive, and that means the bottom is negative, and they're asking you what is the charge in order for it to be able to suspend, okay? The charge is going to have to be negative, okay? Because you need it to repel the bottom and then attract to the top. If you want it to be up, if it's the other way around, the only way that you're able to suspend it is if you have a positive, so it's repel the bottom and attract to the top, because force of gravity always pulls it down, okay? So it has to be negative. So what that means is for part C, you're going to have excess of electrons. Okay, part B, calculate magnitude of the charge of the latex spheres. Okay, so basically you're not just studying the free body diagram. I know there's FG going this way, and I know that that's FE going, and FG have to equals to FE, or do we like to write it the other way? Okay, I'm just going to write it here. Okay, MG is equals to Q epsilon, and I know epsilon is delta V over R for a parallel plate. So I'm going to plug that all in. Mg equals to Q epsilon, delta V over R. Then I'm going to plug everything in and solve for Q. So mass times 9.8 equals Q delta V over the distance between them. So solve for Q, 1.5 exponent negative 15 times 9.8 times 0.025 divided by 460. So I got the charge to be 7.989 times 10 to the negative 19 coulombs. Put it in the correct signics. I would like two significant digits, so 8.0 times 10 to the negative 19. Okay, so now part C, we already talked about it because I have a negative charge. That means I will have excess of electrons. So how many is Q is N times E. Q, we got it to be 8 to the negative 19. N is what we're looking for. 1.602 times 10 to the negative 19. So I'm going to have to divide whatever answer I got just now. Okay, N is equals to 5 electrons. Okay, so there are 5 electrons within this mass.